Hi, my name is Emily and I stopped eating for 2 weeks to get thinner. I read online if you are feeling hungry, drinking a glass of water or eating chewing gum will make it go away. If I still feel hungry at night, I will eat baby carrots and a Diet Coke or just go back to sleep to forget the hungriness. However, by the end of the first week, I feel so sick. On top of being depressed, I have a bad headache, my hair is falling off, and my skin feels so dry. It got worse day by day until one day I almost fainted at school. I was sent immediately to hospital due to slow heart rate and abnormally low blood pressure. Once I came to, I told the doctor everything, that I starved myself to become thinner. The doctor explained that starvation caused severe calorie deficiency below the level needed to sustain life. More energy is used than consumed to keep the cell functioning, forcing the body to enter survival mode. There are 4 stages of starvation. First phase is when insulin is used for glycogen synthesis. Phase 2 is when you are fasting from 4 to 12 hours, it increases glycogenolysis. Third stage is early starvation, it increases gluconeogenesis. And last stage, increased lipolysis followed by ketogenesis. First metabolism affected by starvation is carbohydrate metabolism. It can be divided into 2, glycogenesis and gluconeogenesis. Glycogenolysis is breakdown of glycogen to glucose. It consists of 3 steps. First, you must release glucose 1-phosphate from glycogen activated by glucagon. Next, glucose 1-phosphate will be converted into glucose 6-phosphate by enzyme phosphoglucomutase. And lastly, glucose 6-phosphate will become glucose by enzyme phosphatase. Up to 12 hours of starvation, gluconeogenesis will occur because glycogen store depleted. It is a process of synthesis of glucose from non-carbohydrate sources such as amino acid, pyruvate, and lactate. Precursors such as pyruvate enter Krebs cycle and converted into oxaloacetate, which is starting material of gluconeogenesis. It then bypass series of reaction to PEP by PEP carboxynase to 3-phosphoglycerate, 1,2-biphosphoglycerate, fructose 1,6-biphosphate, fructose 6-phosphate, glucose 6-phosphate, and lastly become glucose to generate energy. Moving on to last stage of starvation, which is the 4th one, it is called late starvation. It affects lipid and protein metabolism.
Now let's try to understand lipid metabolism. During starvation, lipogenesis, formation of fat, is slowed down, while lipolysis, breakdown of fat, is accelerated. So in lipolysis, triglyceride degraded into fatty acids and glycerol. In mitochondrial matrix, fatty acids undergo beta oxidation to generate acetyl-CoA. Each round of beta oxidation removes 2 carbons from the fatty acid chain, releasing 1 acetyl-CoA, which can then be oxidized in the citric acid cycle. Beta oxidation also produces several high-energy FADH2 and NADH molecules which are fed directly to the electron transport system. Ketogenesis is when acetyl-CoA is produced in excess. It is diverted to create ketone bodies, acetoacetate, acetone, and db-hydroxybutyrate. Acetyl-CoA is catalyzed by thiolase to form acetoacetyl-CoA. HMG-CoA synthase catalyzes conversion of acetyl-CoA to HMG-CoA. HMG-CoA form acetoacetate by HMG-CoA lyase. Acetoacetate can be converted into acetone or db-hydroxybutyrate by db-hydroxybutyrate dehydrogenase. During glucose starvation, ketone bodies are an important source of fuel, especially for the brain. However, ketone bodies are acidic and when produced in excess can overwhelm the buffering capacity of blood plasma, resulting in metabolic acidosis, which can lead to coma and death. Ketoacidosis is a serious complication of diabetes, in which cells must oxidize fats for fuel as they cannot utilize glucose. Extreme diets that are excessively low in carbohydrates and high in fat may also result in ketoacidosis. Now let's try to understand protein metabolism during starvation. When oxaloacetate is used up from the lipid metabolism in the Krebs cycle, acetyl-CoA will undergo ketogenesis. In starvation, process ketogenesis increase, ketolysis decrease. During starvation, ketone bodies are produced by liver, released into blood and being used by brain and heart as a fuel, because there is an insufficient amount of glucose to fuel our brain, heart and muscle. The body uses the proteins within muscle tissue as a fuel source, which result in muscle mass loss. Amino acids become the major source for glucose homeostasis because of the decrease in plasma insulin level and the rise in glucose glucocorticoid level. Muscle protein degrades into amino acids. Amino acids undergo deamination or transamination to form the gluconeogenesis inputs, removal of the amino group to produce keto acids. Some amino acids can be directly deaminated while others must transfer the amino group to alpha-ketoglutarate to form glutamate, which is then deaminated to recycle alpha-ketoglutarate. Depending on the side chains, keto acids from different amino acids may enter the metabolic cycles at different points. They may be converted to any of the intermediates of the citric acid cycle such as pyruvate, oxaloacetate, alpha-ketoglutarate or others and converted to glucose via gluconeogenesis. Depletes hepatic glycogen and boosts gluconeogenesis. As starvation progresses, gluconeogenesis decreases in the liver but increases in the kidney as ammonia excretion increases. Nitrogen excretion reflects this change. As fasting progresses, urea excretion decreases and ammonia excretion increases, correlating with increased renal gluconeogenesis. Deamination produces ammonia, which is toxic if accumulated. The liver converts ammonia to urea to be excreted in urine. Prolonged starvation, ketone bodies may be a major fuel. This can accelerate protein metabolism, which can cause death due to loss of liver and heart function.
In conclusion, we learned how our body works upon starvation and the effect of starvation to our body. The main key of this video is once our body runs out of carbohydrates, lipid and protein will be used as backup energy through gluconeogenesis. And lastly, ketone bodies will be used as main source of energy instead of glucose.